Hi, I'm Jason Brown from DDN. As AI models grow, they're moving from early models with millions of parameters into mature models with trillions of parameters. When you combine that with massive multimodal data sets, text, images, videos, embeddings, and the need for high concurrency, you're dealing with workloads that look like supercomputing workloads. However, these demands go far beyond what traditional enterprise IT was built to handle. NVIDIA, the company driving both supercomputers and AI infrastructure, has recognized this shift from HPC to AI. And what they've discovered is that the same data infrastructure backbone that underpins HPC and supercomputers now underpins large-scale AI. HPC delivers three essential capabilities that AI absolutely requires. The first is massive parallel compute and data workflows, training models across hundreds of thousands of GPUs, reading millions of files concurrently. Next is high performance, high throughput, low latency I/O. Supercomputers have extreme demands for bandwidth and consistency, and AI workloads are now at that level as well. And then we have massive scale. Distributed compute coordination, large-scale orchestration, fault tolerance, and performance at scale built in over decades of HPC work. But here's the critical part. HPC is the foundation. It gives you the platform, but by itself, it's not sufficient for modern AI. So you might ask, if my company already has an HPC stack, why do I need additional AI infrastructure? Well, the difference is now you're dealing with billions, trillions of small objects, embeddings, and massive metadata lookup. And therefore, scaling AI demands more than compute and classic file block systems. You also need a data intelligence layer on top of this HPC foundation. The data intelligence layer provides a few things. Obviously, high performance object storage, not just file or block. Support for multimodal data like images, video, sensor streams. Metadata and data intelligence services to manage, find, move, and govern data. Workload unification across all your various multi-protocols. And hybrid cloud flexibility to move or burst seamlessly across environments. In short, HPC provides the bedrock. The data intelligence platform that sits on top enables AI at factory scale performance. So when you combine the foundation of supercomputing with a robust data intelligence layer, you have the perfect recipe to power AI factories, providing faster training and tuning of large models, higher GPU utilization and lower idle time, the ability to scale models from hundreds of billions of parameters towards trillions, unified data across file, object, cloud, and on-prem, better governance, lower cost of data movement, and less complexity. That's what separates companies that just run AI from those that scale AI. Supercomputers built the foundation of the data-centric world. And now that foundation, when combined with intelligent data infrastructure, is powering this AI factory era. Thank you for your time.